Back to Math 31. This is a lesson on factoring trinomials, so still the second part of the review on factoring. Now, factoring trinomials, you'd be hopefully familiar with these. You would have done lots before. I'm going to deal with some tricky ones, I guess, for lack of a better word. So the method that I use to factor trinomials is something like this. I break down the first term, and then I break down the second term. So it's trial and error, guess and check. So I would look at 6x squared, and I would try, well, 3x and 2x. And then the 1, I would break it into 1 and 1. There really isn't a lot of choice with that one. The signs, because they have to multiply to be -1, one of them must be negative, and one must be positive. So I'm going to put the positive there and the negative there. Thinking being that if you go 3x times positive 1, you'll get positive 3x. And then if you cross the other direction, you'll get 2x. Times -1, which is -2x. When you add the two together, you get 1x. Now, I know you're probably familiar with this, but that's a variation of a very common method. So it factors into 3x minus 1 times 2x plus 1. So that little cross method is just the OI part of FOIL. Now, number 2, I would recommend that you rewrite this one with the leading term -4x squared. So in descending order, plus 4x plus 3. I would also advise you to take a factor of -1 out, so negative, and that would leave you with 4x squared minus 4x minus 3. And then factor this using the same method. And 4x, I will try 2x and 2x. The 3 will have to break into 3 times 1, so you just have to decide where to put each number and then the sign. I'm going to go negative and then positive. And then when you put the whole thing together, that does work, by the way. That's positive 2x. That's negative 6x. So together that's negative 4x. So this thing will ultimately factor into negative. And then we have 2x minus 3, and then 2x plus 1. Okay, the next one, these two, I'm not going to do them both because there's so much redundancy with them. If you want to try number 3, easy to check your answer just because it's going to work out by foiling. You can take it back and see if you got it right. But number 4 will interest us a little bit more because we here have a greatest common factor that should be removed because each of these terms can be divided by -2. You can also divide by xy. And if you do that, you'll get 40 x squared plus 61 xy plus 18 y squared. So the common factor of -2xy took us to that point. And then the -2xy, of course, is just a passenger on the outside. And we break this 40xy. Well, it could be a lot of things, 4 and 10. It could be 1 and 40, 2 and 20. But I'm going to try 5x and 8x. And then the 18 could be many things as well. I'm going to try 9y and 2y. So they have to multiply to be 18y squared. Everything is positive. So now when you check, 5x times positive 9y will give you 45xy. And then the 8x times the 2y gives you 16xy. Add those two together, and we get what we wanted, which is 61xy. So in fact, this thing is going to factor into -2xy multiplied by 5x plus 2y multiplied by 8x plus 9y. So that's an example of, or a few examples of trinomials. So you want to make sure that you're on top of it. But the next batch of questions is going to probably break a little bit of ground because it is new. It's also probably new. It's also a very common thing for this unit. We'll be using this particular type of factoring a lot to simplify a specific type of problem down the road. And I've just labeled it non-natural exponents. Now, non-natural exponents, well, here's a few examples. It just means that you don't have exponents like 1, 2, 3, 4, 5, or anything like that anymore. Rather, they will be negative or even fractional, as you can see with these. So for this first one, 3x squared minus 6x to the negative 2 plus 9x negative 1, the key is that we do take a common factor out. And the 3, I think you'll be able to recognize right away. So GCF is going to be 3. But then with respect to the x's, and we follow the same rule that we have always followed, is that we take out the smallest exponent. So when you see you have x to the 2, you see you have x to the negative 2 and x to the negative 1, you remove x to the negative 2. So look for the smallest exponent. And that's the rule. And that's the rule you follow for natural exponents, and you also follow it here. So I'm going to divide each of these terms by 3x to the negative 2. Now you're not going to see much improvement on the basis of this, but when we do get to a specific type of problem, you will benefit from having done this. Now also be very careful with the division, because I showed it in this step that I'm dividing each of those terms by that factor. So 3 divided by 3 is 1, but don't forget when you're subtracting dividing powers, you subtract the exponents. So this is x to the 2 minus negative 2, which is going to leave you with x to the 4. So that's the critical part. You have to make sure you do that division properly. And almost, if you have a negative exponent, you'll end up adding it. For the second one, 6 divided by 3 is minus 2, all right. And then x to the negative 2 divided by x to the negative 2 is gone. And then this one, be careful as well. The 9, or it should be a 3 down there. This will give you plus 3, but then when you go x to the negative 1 minus negative 2, so subtract the exponents, you'll get x to the negative 1 plus 2, so that becomes 3x to the 1, and then you're done. So that's the trick, to make sure that you do that, the exponent properly. And also that you take out, the rules still apply, you take out the smallest exponent. Smallest also in terms of on the number line, so the smallest, the negative one. So in this case, the GCF, 2, 4, and 8, well, we can see we take out a factor of 2, I think, from all of them. But then the x, we have x to the 3 over 2, x to the 1, and then x to the negative 1/2. So we take out x to the negative 1/2, or we divide out x to the negative 1/2. And in doing so, very carefully, the 2's will divide out, and I'm not going to write this every time, but x to the 3/2 minus negative 1/2. And that's going to become x to the 3/2 plus 1/2. 3/2 plus 1/2 is x to the 4/2. So we actually end up getting x to the 2. And then the second one is x to the 1. Now 4 divided by 2 is 2, so the numeric part's easy. But then this is x to the 1 minus negative 1/2. So that becomes x to the 1 plus 1/2. Now if you add those together, 2 over 2 plus 1 over 2 is x to the 3 over 2. And then finally the last one is plus 4, and these cancel, divide right out. So that's the idea. Let's try a few more. Now they get more complicated, unfortunately. And this is an expression you may not even think that you could factor. But if you put it in exponential form, so x plus 4 to the 1/2, and then plus 2, x plus 4 to the 2, we can now look for common factors using the same rule. We divide out by the smallest exponent. So this would be x plus 4 to the 1/2. And then we divide this one by x plus 4 to the 1/2. So that's going to leave you with just 1. Oops, as soon as you write out your x plus 4 to the 1/2, that is. So we have 1 plus 2, and once again, deal with your exponents with care, because you're going 2 minus 1/2. So 4 over 2 minus 1 over 2 is 3 over 2. And there we have it. So that's the method that we use. And it works very well for many of these questions. In fact, it works really well for all the questions. Now, number 4, again, stop me at any time. Be careful with something like number 4, because you need to recognize that that x squared minus 1 on the bottom, square root of, in exponential form is to the exponent of negative 1/2. So the square root is 1/2, and then bringing it to the top. So we need to do that, and that's usually the first big problem. Minus 8x squared minus 1. To the positive 1/2. Now, the GCF that we can remove is clearly 4, the numeric term, and then x squared minus 1 to the negative 1/2 should be removed, always the lowest exponent. And that'll leave us, well, the first term, it leaves you with nothing, or with 1, excuse me, not nothing. And then the second would be 8 divided by 4 is 2. And I'm not going to show the division with this, but when we go 1/2, x squared minus 1 to the 1/2 divided by x squared minus 1 to the negative 1/2, we add the exponents. So 1/2 minus negative 1/2 is 1/2 plus 1. So we end up with this. And that's good, because then that means that we have 1 minus 2. Now we can distribute that in, so we get minus 2x squared plus 2. So in fact, this is leading us to a good simplification. And then this would be 3 minus 2x squared. And the factor of 4 would be there. And then on the denominator, we have x squared minus 1 to the positive 1/2. So I'm putting it back on the denominator to keep the exponents positive. Now you can also write that, in fact we'll start seeing it more often, where it's returned back to the radical form, so x squared minus 1 square root of. No, I'm going to leave number 5 because it doesn't really do much new for us, but let's go on to number 6. Now this number 6 introduces a new concept for us because we have the fractions in front. And now we're not used to taking out common factors when you have fractional terms. So we want to make good decisions on this. What I would recommend for one like this, with 2 over 9 and 4 over 3, we want to take out a number that's going to get rid of the fractions. So to get rid of the fractions, we follow the same rule, but we take a look at the top, and we take a look at our numerators 2 and 4. And you treat it the same way you normally do, which is that you take out a common factor that is the smallest number that goes into 2 and 4. So the GCF of 2 and 4 is going to be just 2. And then 9, this is actually 1 over 9 and 1 over 3. And the smallest number of 1 over 9 and 1 over 3 is 9. So we again take out the smallest number that is represented. It is the greatest common factor, but it will be the smaller of the two numbers. So 2 over 9 comes out, and then we also take out an x minus 4 to the negative 3. Now if you didn't make the best choice, you'll know right away. Because now when we divide it out, that first term it just turns into 1. But what's interesting is when we take that 4/3 and we divide by 2 over 9, it becomes 4/3 multiplied by 9 over 2. And you'll see what happens. We get a cancellation. So the 4 and the 2 simplify to 1 and 2, 3 and 9, 1 and 3. So we're left with just 6, which is what we want. And then x minus 4 to the negative 2, not writing it, but that negative 2 minus negative 3, when we divide, becomes negative 2 plus 3, so which is 1. So we end up with this. So this is now 2 over 9 multiplied by x minus 4 to the negative 3 multiplied by 1 minus 6x plus 24. Should be 1 out there. And then that would be 25 minus 6x for that term. And then I'm going to take that x minus 4 to the negative 3, write it on the denominator, and then meanwhile we have a fraction of 2 over 9 multiply this. So if that 2 is there, we have to put a bracket around it. So we can write it just like that. Or you can put the 2/9 in front, but this is the more common way to do it. So you get rid of your negative exponents. Now, had you taken out a fraction other than 2/9, then you would have ended up with a fraction within the bracket, which is not wrong. It's just it's harder to simplify. Now, let's do number 7, and I think that will probably do us. And pause me at any time. But when we're taking out numbers, the number 4 over 5 and 4 over 15, well, the numerator has to be a 4. Now the question is, here this is 1/5 because 5's on the denominator and 1/15. We want to take out the 15 on the bottom because that is the smaller number. 1 over 15 is smaller than 1 over 5. And then we will also take out a factor of x plus 2, Well, the biggest or the smallest exponent on the number line is negative 5 over 4. So that's your GCF. And when you divide that out, I hope I have enough space here, we're going to be left with, now down below I'll sneak this in, 4 over 5 divided by 4/15 is 4 over 5 times 15 over 4. 4 is divide out, 5 is gone, and we're left with 3. And that's what we want. So we have 3, we have x still there, and then the x plus 2 to the negative 5/4 will divide away. And then the 4/15, because that is our common factor, will go away. It's just a 1. And then we carefully get our binomial. This becomes x plus 2. And then negative 1 over 4, I'm not writing this, minus negative 5 over 4, we add. Okay, I will add. Negative 1 over 4 plus 5 over 4 will give you 4 over 4, which is just 1. Perfect. Because that will take care of that expression. So really now we've got 4/15 times x plus 2 to the negative 5 over 4. And this is going to be multiplied by 3x minus x minus 2, which is 2x minus 2. We factor out a 2, and that will leave us with x minus 1, and this is going to be multiplied by 4 over 5 times x plus 2 to the negative 5 over 4. And then when we multiply that all together, we get 4 times 2 is 8, and then that would be multiplied by x minus 1. And then we have a 5 on the bottom, multiplied by x plus 2 to the negative 5 over 4. And there we go. So we factored it using those principles. So that's how these ones go. Got to be very careful with them, but mastery is important for for a couple units from now. So I'll stop right there. And the next lesson will continue with factoring, but doing some four-term polynomials, so grouping and division. Thank you for your time.